So that we can now start solving nth order homogeneous differential equation, let's talk about the form of the solution once we can identify that the roots of our auxiliary equation are actually distinct, meaning they are unique. There's no multiplicity of 2, and all of them are actually considered to be real numbers. This is how we write auxiliary, the solution. If we have this situation, we have here y is equal to your c sub 1 e to the power of your first root x plus c sub 2 e to the power of your second root x plus plus until c sub n e to the power of m sub n x. Okay? So say for example, we have an equation and we have guaranteed that after identifying the auxiliary equation and the roots for that, they're all distinct and real. By the way, I'm no longer going to write the entire process because we have separate videos discussing the methods and what are auxiliary equation. Okay? This corresponds to m number of roots. Okay? Say for example, just for example, we also have examples later on. If our roots are actually 1, 2, 0, and negative 5. Take note that they are all real roots and they are distinct, meaning they are unique. None of them have multiplicity of 2. So this time, we are going to use the solution. Okay? So for whatever would be that homogeneous differential equation, we're able to gather all of these roots here. Again, we are to identify them in a process, but if we have them already as the roots, this will be our solution. Y is equal to c sub 1 e to the power of your 1 times x as your first root plus c sub 2 e to the power of your 2 times x plus c sub 3. Okay, you have e to the power of 0 times x and plus, let me write it here, c sub 4 e to the power of negative 5 times x. Okay, so every root has its term. So our solution here is simply c sub 1 e to the power of x plus c sub 2 e to the power of 2x. You have here plus c sub 3 e to the power of 0, right? And you have here plus c sub 4 e to the power of negative 5x. Or you can rearrange it in this manner and of course simplify this. Okay, not that one, I mean this one here. So you will have here c sub 1 e to the power of x plus c sub 2 e to the power of 2x plus c sub 3 plus c sub 4 e to the power of minus 5x. If you wish to rearrange this, you may. Take note that it's addition and addition is commutative. And at the same time, you can also have other versions, by the way. If you think that you were able to solve this as your m sub 1, this was your m sub 2, this was your m sub 3, and this was your m sub 4, definitely you will have a different form than this. Okay? And it will be paired with different constants here, c sub 2, c sub 3, c sub 4. It's still acceptable as soon as you will write it carefully together with its proper representation. My point here is that since they are all under addition and these values of c sub 1, c sub 2, c sub 3, and c sub 4 are arbitrary constants or real numbers, so they can also take other values and they can take any place somewhere here. Okay? They can take any place in that given solution. Nevertheless, this is one version of the solution if you will have the roots identified here. So basically, your solution here will matter on the roots of your auxiliary equation, and you are to start solving that using the intended process. But this is how we write the solution for the nth order homogeneous differential equation if the auxiliary equation has m distinct real roots. It differs now to other situations as well. Thank you very much for watching.